Hello student, welcome to the video. Today we are going to start with the new one of the most important topic in mechanics, speed, velocity and acceleration. These concepts are the building blocks of physics and you will see them again in motion in straight line chapter and projectile motion, circular motion and even modern physics. So let's understand this concept with formulas and some of them derivatives and their graphs. So first one is speed. So most of you are familiar with this term speed, which is distance traveled per unit time. So let's say if A to B is some distance, let's say x, some unit kilometer, and time taken in this is t hour, then speed is distance upon the time. So distance in this case x upon t, so kilometer per hour. So it is a scalar quantity and only has magnitude, no direction. It means you can say that these are Cartesian coordinate x, y and z, but in our case we are not mentioning these Cartesian coordinate. We are just saying that a person or a random walker is traveling from some point A to some point B. That's it. So speed can be uniform or non-uniform, uniform and non-uniform, non-uniform. So uniform means equal distance in equal time, and non-uniform means unequal distance in equal time of interval. So then average speed we average, suppose that is total distance upon total time. And then instantaneous speed. So let's say if someone is traveling from A to B and we have to calculate at points somewhere between A prime, and at that point we have to calculate, let's say this particle or this person's instantaneous speed. Then V instantaneous is equals limit del t tends to 0 del s upon del t. Del s is change in distance, and del t is change in time. So let's say if we have to draw the graph of this quantity, then on the x-axis we have to take the distance s, and on the y-axis it's t. If say let this plot is a straight line, and you have to remember the straight line formula, which is y equals mx plus c. M is slope and c is constant, and this constant decide whether this line will pass out from the origin or some other point. Let's say if this line goes from there, then the value of c will change, and if this line goes here or here, anywhere here, so that is the basically difference between these phenomena. So we have to only measure the this formula with this simplest form, and which is this one. So the slope of this is velocity, so the slope of this is speed, which is s upon t or del s upon del t, which is this one. So the point of this is this and this. Let's move further. Second is velocity. So if distance becomes displacement, then speed is defined as velocity. In the speed there is only magnitude and no direction. But in velocity there is magnitude as well as direction. So if some quantity have magnitude as well as direction, then these quantities are known to be vector quantities, and if it's not, then it will scalar quantities. So these are some basic points of this phenomena. So is velocity rate of change of displacement with time. So in other forms, velocity is displacement upon time, or let's say displacement is x, then change in displacement is del x and del t. Remember the unit for speed as well as for velocity are same if calculated in same unit system. So you have to remember these points. And then average velocity, that is also here v average, that is dxy dt. And let's say instantaneous, so instantaneous will be v instantaneous, same as speed, limit del t tends to 0 del x over del t, or sometimes we have to write it as dx upon dt. It means the derivative of x with respect to t, dx upon dt. For biology background, this will be new. So dx upon dt is derivative of x with respect to time t. So let's say if graph between velocity and time is straight line, so the slope will be sorry, the graph between displacement and time is this one, a straight line, then the slope of this will be del x over del t, which is velocity, and if it is a straight line, then it is constant velocity. Constant velocity means velocity is changing with time constantly. Further, now let's take an example of a runner running around in a circle. So this is a circle, and the track radius is 50 meter, let's say, and a runner around this circular track of radius 50 meter and comes back to the starting point. Let's say this is the starting point of this circle A, and this runner is running like this. So back to the starting point in 20 seconds. So t will be 20 seconds. So let's see 20 seconds, and so distance covered by this runner is the circumference of the circle 2 pi r. So that will be 314 meter, and then speed will be, that distance divided by that time. So something like if it in meter, this is in second, then it will comes around 15.7 meter per second. So let's say if I am saying that we have to calculate the velocity, so in velocity we are not required to the distance. Instead of that, we have to calculate the displacement. So displacement in this case is 0, because that person goes around this like this and come back to the same point where he started. So displacement delta x is 0 in this case. So velocity in this case, velocity is 0. So because displacement is 0. Third is acceleration denoted by a. So let's see, acceleration is a rate of change of velocity with time. It means a will be rate of change of velocity with time, del by del t. So formula is simple. If let's say a person is starting from point A to point B and running like this, so if the starting velocity is u, final velocity is v, then a will be v minus u by that time. So I hope you are understanding the point here. Furthermore, the uniform acceleration is change in velocity. Non-uniform, change is not constant. So slope, let's say if we have to draw the graph of this, is like this, and velocity, time. If simple line, it means straight line, then the slope is del v by del t, and which is acceleration. Okay. Further, in this case, we have now move on to equation of motion. Let's see. First equation is, as we previously seen, v equals u minus v, change in velocity upon time, then v equals u plus at. It is first equation of motion. First equation. Now second equation, displacement. What is displacement? Let's say second. Displacement is area under velocity time graph. So let's further see this point like this: velocity, time, a straight line, and the area under it means, let's say we have to calculate from this point A to B, then area under is only this one. Okay. So as is, displacement is area of rectangle plus area of triangle, which I'm sure you have seen in your book, which is S equals to UT plus half AT square. There are some other techniques to do this, but it is simplest one. So let's see. Furthermore, third equation, this one is second equation, and let's see, from V equals to U plus AT, first one. Second one is, so T will V minus U by A. and second one is s equals ut plus half at square. So let's substitute t in. So v square minus, oh wait a second, v square minus u square equals 2as, which is third equation. So what have we learned from so far? X, t, t, and then this is velocity. Velocity, if it's displacement, and if it is a velocity time, then the slope will dv by dt, which is acceleration. And some of the real life example, like speedometer of a car shows instantaneous speed. It means you have, I'm sure you have see the speedometer of car. So there are like this and like this. So we have note down the, suppose if car is running at per hour, it means that instantaneous speed of that car is 60 km per hour. Velocity is important in navigation because direction matters, and acceleration explains how quickly rocket cars or falling object gain speed. So to summarize today's lecture, speed is distance upon time, that is a scalar quantity. Velocity is displacement upon time, which is vector quantity. Acceleration is rate of change of velocity. And then graphs, we have seen all of them, and three of equation of motion. So that's it from my side.